Last week it was the nuts and bolts of confidence intervals. The very last question where it said, suppose a study gives you a p-hat value and a sample size. Could you construct a confidence interval? And you all said, yeah, you can. And then I said, if you can, construct it below. I think that caused confusion amongst folks, and I apologize for that. A bunch of people said, well, you didn't give us data. I'm like, well, I know. I wanted you to do it in general, for a general p-hat and a general n. So what you would have done was actually just gone p-hat plus or minus 1.96 root blah, 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 blah. And so a couple of you did that, and I'm stoked. But a couple of you said, you didn't give us data, so I'm either going to make up my own data, which I loved, and then you made your own interval up. Fantastic. You got points for that. If you didn't get points for that, come see me. And a few of you took data from another thing that we had done in class, which is great, and that was fine too. So I apologize. I think I made it too abstract, and I apologize for that. It was the first try for a quiz, so I get to give it a whirl. So thank you for teaching me that it was too abstract. I'll touch it up next time, and I'll actually throw some numbers in there to make people happier. So I don't want to upset anybody, obviously, but I think I succeeded in upsetting a few people, and I apologize for that. So you pretty much kicked ass on it. I just wanted to let you know that that's why some of you are going to have correct answers, but they look nothing like each other. Does that make sense a little bit? Hopefully it makes a little bit of sense. So that was fantastic. What else? Oh, a goof this week, or next week, sorry. Thank you, Amaya, for telling me this. There's a quiz on texting and driving and drinking and driving and reading and text and driving that's posted for this week, because a bunch of you did it. Apparently I posted the same quiz for next week because I'm an idiot. I have my quizzes labeled with short acronyms in my little server, and I had 2 ready to go, and I think I just grabbed the wrong one for next week. So I'll fix it for next week, and I'll put another one up for you guys on for Tuesday. So I'll just don't worry about this one. If you turned it in today, yay. If you didn't turn it in today, I'll put a secondary one up for you for next time around. Thank you for letting me know about that on my end. Otherwise, I would have never known. Somebody told me. It's Tuesday because your exam's Thursday. Yeah, I mean, it just seems silly to have too much on one day, since the exam is like super quiz, if you will. Thank you for mentioning the exam again, Linda. Remember that's due in a week. Email me if you get stuck with anything. There shouldn't be too much to give you issues. There's not much technology to use, except for your TI and or whatever program you're using to do the statistics. And there's one web page you have to pop out to. That will, I think I told you this last time, if all of you go there at midnight, it's going to lock up on you. So try to not do that. Try to get it done ahead of time. Cool? If you get stuck, it's 2 in the morning and you're working on this thing and you're getting stuck, remember you have all those homework sets, those extra resource pages full of stuff. Just extra stuff that will probably help you through some of the questions if you get stuck. You can always email me, of course. But at 2 in the morning, you'll have to wait 2 more hours till I wake up. And then I won't get it until 6. So just remember those extra resources are there. There's lots of stuff there for you. Cool? So any questions on grades, just grab me at the break and we'll figure it out. And we'll take a look at what happened. This is a running total collection of the data you guys have given me. And I say you guys and lots of classes before you have given me. These are the last 3 questions on the project you just turned in. So when you turn in the last 3 questions, it was that silly rectangles question where you pop open a page and it stays there for 10 seconds and then goes away, and I tell you to guess what you think the average area is, okay? And then I say, okay, now go back, open the page, and leave it open as long as you want, and try to figure out what the average area is by picking, I think I said pick 5, what you think 5 representative rectangles look like. And then the third is the random choice 5 rectangle. That's the third way you had to do it. So you had to give me 3 areas on that project. So what I did was I went ahead and graphed the results over time, because I love seeing this over time. I love seeing more and more data done the same way. It goes back to, I think it was Veronica, told me about replication of studies. Seeing a study done over and over and over again to see if similar trends occur. And the first thing I noticed about the trends that are occurring is that what are the predominant shapes, except for these goofy tails, which I can't explain, what are the predominant shapes of your responses? Why? Hell if I know. You guys guess in bells. I don't know why, you just do. I've told you before in 243, lots of stuff shows up bell-shaped. We can add one more thing to that list, the way you guys guess at random rectangles. Did that problem seem familiar from 243? A similar problem we did in 243 on the very first day of class? Princess Bride, Middle Montoya, guess the average length of the word in the soliloquy? Yes, same thing, same exact idea. So I wanted to see how it translated to pure geometry. So when I look at here, this was the random guess. And it's a pretty wide bell curve with this, again, I can't explain this. I can't explain the hump at the end, whatever, it's there. Find outliers, we can ignore them if you want to. Because some people just misread the question. Like they put down an average area of 120. Well, there are no rectangles that are even close to being 20, not let alone 120, so I threw those out because obviously the calculation was wrong. So here, if you had to guess for that blue graph what the average was, you can ignore the outliers because that's going to inflate it. What would you say the average was for that graph? And don't make a confidence interval. There's no reason to do that. Just what would you call the area? Guy says 9? No, Linda says 9. Yeah, I think so. Somewhere about in here. Maybe 8, 8.59, somewhere in that general. That's where you have to balance it, correct? If you include those, it would definitely move further that way. So somewhere around 9. Very, very good. Very, very good. When you had time to decide and pick 5 rectangles of your own, what was your area? The red histogram behind it. What was your area? It hasn't changed, has it? But what has changed? The average hasn't changed, but what has changed? And again, you could ignore these because I can't explain those. So ignoring those outliers down at the high end, what has changed between the blue and the red curves? So, Emily, go ahead. Good. Twice as many? 20 to 10, or no, yeah, 40 to 80. So many more of you are getting close to that spike. In other words, the variation has shrunken down quite a bit. When you have the time to sit back and go, okay, I'm not guessing, I'm actually looking. Okay, that one, that one, that one, that one. So it seems like by allowing you to have that time to kind of pick values, you guys get to a more concise. There's far fewer of these tiny areas over here. And also, it looks like fewer of these areas over here, and you start moving closer to the middle. So it's almost the same center of the bell curve, but yet the frequency in the middle is higher, so we're getting less variation. How about the green one? The green one. What's going on back there? That's where you let the computer pick 5 random numbers, and then you go and find those 5 rectangles and average them. What's that one's area? If you had to give that one a number, what would you say? The green one. 7. Guess what? 7 is the average area of those rectangles. Not 9. 7. So you guys missed it by 2. Why did you miss it by 2? Thank you also for that. Thank you for everyone that said 7. Why did you overestimate the area in that picture? I'll pull it up for you while you're thinking about it. Think about why you overestimated.
Must have appeared to be a lot larger.
Let's take a look. I like that. I like that. Did I put them? I put it here. Random rectangle, no numbers. I think this is it. This will do. Yep, there it is. There she is. The average is 7. But you guys guessed too high. On average, too high. Now some of you were guessing correct, obviously. But that was a very small part of that curve where you were guessing correct. So why were you guessing so high? You have to think, what was this project all about? You forgot, you turned it in last week. It's done. Statistics, thank you. Yes, excellent. It's about learning. Yes, it's good. Specifically, what part of statistics? What was the name of the project? Proper sampling. Sampling. And how important it is to have a random sample which is free of, what was that 4-letter bias? Free of bias. How could you be biased with this image? And it's because we're human. Austin.
You overlooked the 1.
Who was looking at these little 1 guys up there? Anybody? It's the same exact thing that happened to you with Inigo Montoya and a soliloquy. How many of the A's and the I's and the 2's did you count? They have to count just as much. That 1 right there has to count just as much as that 16. That 1 right there has to count as much as that, what is that, 18? They all count as 1. There are 100 rectangles up there. 100 rectangles. A sizable chunk of them are singles. See, those little single ones. But your eyes aren't drawn to them, right? Your eyes are drawn to the larger ones. Why? Because we're human beings. Because we're trained by evolution to be that way. Or because we're American and we like big things. Bigger, better. Whatever reason, our eyes are drawn to that. Yes, our eyes are drawn to that, and they're drawn away from those little guys. Hence why the randomizer helps us correctly identify the area by making sure we actually grab representatively from the 100. Make sense? Kind of make sense? Good. And that's, again, whenever you can apply some kind of a good randomization algorithm to get your data. A lot of this class, in all honesty, a lot of this class feels like it's cheating because I'm handing you data or we're collecting it in class together. Now you got to realize, what kind of sample is what we always, whenever we collect data in class, we collect a bunch of it already. We collected your touch therapy, we've collected your stopwatch times, timing 10 seconds, we've collected penny spin experiments. What do we call that kind of sampling? Oh look, how nice, you guys are all here right now. Let's give you pennies, spin them. Oh, yay, you can all spin them, give them back to me. What do we call that sampling from your project? Convenience. Is that necessarily good sampling? No, it's necessarily usually crap sampling. But we're not focused, except for this project, we're not going to worry too much about the sampling methodologies in this class. This class is more about the mechanics, more about what to do with the data once you have it. Anybody going to take research methods or has taken research methods? Dot, you have, right? With Shannon over at OSU, not very many of you are going to take that. It's unfortunate. It's an entire class devoted to the project you just did. Which I know some of you are like, thank God I'm not taking it. But if you're going to be in a research field, you have to know how to collect proper data. Because all the math that we learn in here, as good as it is garbage if the data going into it is garbage. I'd rather have 10 good data points than 500 crappy ones. Whenever I think about that, I think about the guys doing CrossFit pull-ups down in the gym. I can do 500 pull-ups. Really? Do 10 like me. And I show them a perfect pull-up, and they can't. They can't do 5. I'd rather have 10 perfect pull-ups than 500 crappy ones. I'd rather have 10 good, random, representative data points than 500 garbage convenience sample data points. You can do math on both of them, and the math won't tell you if you're right or wrong. The only thing that'll tell you if you're right or wrong is when you lose your job because you made the wrong prediction. Or published something that was false. See what I'm getting at? Maybe. It's kind of early to do. So that's a lot to hit with you at 8:30 in the morning. But the idea, the big takeaway from this whole project was the importance of a proper random sample. So I've done a pretty good job of collecting a bunch of good random numbers for you from the world. We'll also collect more in class conveniently and, biasedly, most likely you're all Math 244 students, so you're probably all thinking about it anyway. But nonetheless, in the world you have to check your data. And it's amazing to me. It is absolutely amazing to me, the stuff that comes across. Last night I found another quiz for 243. Somebody had sent me this one. Let me see if I can find it for you real quick. Stalin, abortion, plague. If I can find this one. I'm not able to. It was a graph showing how many people were killed by Joseph Stalin, the Black Plague, and abortion. And it was slapped up as a bar graph. Has anybody seen this one? Did you see it?
Please scroll up just a little bit.
It only has 3 bars though.
Yeah.
It's not that. You saw it up there?
Right, keep going.
Keep going.
Right there.
This one? Now this one's got more. Let's see if it's close. No, that's U.S. annual deaths. This was worldwide. Stalin, abortion, plague. Let's put deaths on there. I saved it to my email. Images. Oh, there it is. There we go. Boom! That popped across, it was Facebook. Popped across Facebook. People said, yep, abortion's a terrible thing. Terrible, terrible thing. Roe versus Wade, the worst thing to happen. I'm not playing politics here. I'm not taking a stand on Roe versus Wade or abortion. I'm saying that graph is absolute garbage. Why? Give me 2 reasons why it's absolute garbage. The third reason is that the sampling is horrible, but give me 2 reasons why it's absolute garbage. Natasha, number 1.
Populations, like...
Oh! A third reason I wasn't thinking of! A third reason, adjusted for inflation of population. Thank you, sister. Thank you very much. Wasn't thinking about that. Good. So Stalin was 50s, 40s? Check me on that, history people. 40s, 50s? No history people in here? 30s, 40s. 30s, 40s, boom. 73 and on, bubonic plague. 1800s.
1300s.
1300s, thank you, McKenna. Only off by half a millennium. Thanks, sir. Sorry, YouTube world. Okay, good. So population, number 1. Give me 2 other ones. Give me 2 again.
There's no margin of error.
Very good. And there has to be at least a mention of the incompleteness, especially in the 1300s data collection. There's always going to be issues. If you look at old data, like Titanic data, the deaths on the Titanic, depending on which data set you look at, there's variances of 20, 30, 40 people that died. Because everything was written down by hand in 1912 when that happened, 1914 when that happened. I have that right?
That's good.
I'm on the right century, I think. But then you go back 500 more years, and it's going to be even worse. Good. Another reason I hadn't thought of margin of error. First of all, that's wrong. That's about half, if not worse than half of what it should be. Secondly, why only include those 3 things? I didn't bother checking the other 2, just because I knew that one off the top of my head. How about deaths caused by crusades? Wartime deaths, not even included on there, yeah? Not even included on there. How about deaths caused by smoking, natural causes, or I guess not natural causes, but inflating. You remember the graphic from Chris Jordan? 200,000 every 6 months in the US alone from smoking. 200,000 every 6 months. I don't know how far back that data goes, but start collating that. You're not going to get to, whatever, 50 million very quickly. But if you go back far enough, you will. Carly?
Well, I was thinking, I'm looking at the title, because that's not a correct way to...
Biggest killers in history. Yeah, biggest. If you're going to put that title on there, make sure that you also have the other big killers in history.
Yeah, exactly.
Like, for example, when the US took over the United States, or lessons in the US, when we took over the United States from the inhabitants, how many were killed then? Now, I've seen various numbers, anywhere from 50 to 100 million. I mean, basically eradicating a culture. So, I mean, this kind of stuff infuriates me just because of the sampling, the piss poor sampling that does. So I get really, really upset with this. Not because I can laugh at it, you can laugh at it. The problem is, people believe this, and they act upon this. And it happens all the time, and it's usually politically based. It's usually politically based. You're arming yourself with the power to understand this and the problems with this. So keep arming yourself, yes? Keep arming yourself. Yeah, Guy?
Well, wasn't that produced by the
I'm sure it was. Well, yes. That doesn't, again, that's the worst kind. That's putting the bias not only in the graphic, but in the bottom left corner. Sorry, that's a lot of aggression being heard. But the thing is that here's a perfect example of your project in action the wrong way. You guys pay attention to it. Pay attention to it. Make peace with it, and then be able to talk, in an educated manner about it. All right, sampling, good. Let's save that. Let's get there in a rectangle's good. Any other questions you guys have? Let me ask you a question. Do you want to do a geometric proof this morning? I heard an ew.